In question 8, we have to use the standard results for some summations to show that this expression on the left is equal to this on the right. So this is the summation of, if we multiply the r here, we'll get 2r cube minus 3r square minus r. We can break the summation down, so we can write nr equals to 1 r cube minus 3 times the summation of r to n of r square minus the summation of this. For now we need the formula, which I've kept over here. This will be in the formula booklet supplied during your examinations. For r cube, it is, we have the 2 in front, then for r cube we have 1 by 4 n square n plus 1 whole square, and you have minus 3 times, for r square you have 1 by 6n n plus 1 2n plus 1, and the summation of r, this is basically an arithmetic progression. This will be, for an arithmetic progression, the sum is n by 2 2a plus n minus 1 times the common difference. The common difference here is 1, so this is what we'll get. A over here is 1 as well, so this is what we get. So we'll get half n and n plus 1 over here, so minus half n plus, we get half n square times n plus 1 whole square minus half n times n plus 1 times n 2n plus 1 minus half n times n plus 1. We can take half n times n plus 1 common from everything over here. We'll get n times n plus 1 minus 2n plus 1 minus 1. So this will be half n times n plus 1. Inside the bracket we'll have n square plus n minus 2n minus 1 minus 1. The next line will have n square minus n minus 2. Now if we factorize this, if we're factorizing this, we'll get plus 1 times n minus 2. So if we write that over here, we'll get half n times n plus 1 times n plus 1 times n minus 2. We'll get half n times n plus 1 whole square times n minus 2. This is what we had to show in this question. So that's it for part A. Now we have to show in part B that for all positive integers n, summation of n to 2n for the same thing is this expression over here. So for the same expression, we need the sum from n to 2n. we'll have we can write this as the summation of 1 to 2n for this expression, which we know, and then we subtract the summation of 1 to n minus 1 for the same expression. So 2r. The formula for this would be 1 by 2 n. So this formula over here. Then we'll have 2n plus 1 squared and 2n minus 2. Then you subtract half times n minus 1 times n minus 1 plus 1, so n squared, and then you have n minus 1 minus 2, so n minus 3. We can also write this like this, or half into 2n times 2n plus 1 whole square times 2 times n minus 1. I'll separate this because there is a n minus 1 over here as well, so we can take that out. So we'll get half from here. We can take half into n minus 1 common for both. Then we'll have a 2 from here and a 2 from here, so 4 times 2n plus 1 whole squared, and from this equation we'll have n times n minus 3. Here we'll have half times n minus 1. Inside the bracket we'll have 4 times 4n square plus 4n plus 1 minus n square minus 3n plus 3n over. So half into n minus 1 times 16n square plus 16n plus 4 minus n square plus 3n, half n times n minus 1, 15n square plus 19n plus 4. If we factorize this term over here, we'll get 15n plus 4 times n plus 1. So we'll get half n minus 1 times 15n plus 4 times n plus 1. So this is the equation shown. Here we have a equals to 15, b equals to 4, c equals to 1, d equals to 1. So 15, 4, 1 and 1. That's it for question 8.